Okay, so yeah, after teaching this idea, so we decided to make this exam to 12%, same as other exam. And yeah, so basically this part was mostly about the key constraint, entity constraint, and the reference constraint. So let's get started. Okay, so firstly, we're gonna go over all these definitions. Basic definition you guys need to know for the solving all these problems. And the second part is about integrity constraint, these three types. And the last part is I made some practice questions. Okay. And so basically we in this stage, we want to use mathematical words to describe our table with a more kind of like a serious definition. So we have four kind of like technical terms in our table. Firstly, it's called domain. If you guys ever look at the slides or the textbooks, I don't know if you guys really read the textbook slides. But yeah, firstly about domain, and the second part is the tuple, and the third part is the schema, and the last part is the state. And yeah, so what is the domain? So from the math, we know domain is the kind of like function domain, right? The range of the y can varies according to the x. I have a small kind of like a quiz here, if you guys know this. So what is the domain for the function tangent 2x divided by 2? Any ideas?
Isn't it negative infinity to infinity?
Yeah, almost correct, but almost there, yes. But actually, the solution is the oh, okay, there's one people attending in person, but I haven't opened the remote. Yeah, give me one sec. Could you guys
All
wait?
right, no rush, no rush.
Yeah, I haven't opened the projecting to the slides because there's no one attending in person. Give me one sec.
No one.
Yeah, you're the only one.
He's calling me no one. Look, there's one person attending online so far, okay?
There are 2 persons attending online. Yeah.
One of them is.
I mean, I wouldn't count myself as a person, sure.
Oh, bro.
Yes, there's one person there.
There's one person online. So
Yes, there you go.
Sarah, so I bet you probably should come here.
And I didn't have time to go home, you know?
Nice. Okay. Okay, let me turn on the projector. Give me a second. Okay, I was wondering how I turn on the projector. No,
No, you can hear it with, are you taller? Because it's just that one green button.
okay.
The green button first. The green button. That's it. Fine. I literally just had to fix it. I have the same issue just now.
Okay, because no one can use it. I'm very tired.
No, you're fine. Good.
Okay.
You know.
Okay, I backed. Sarah, I think I just fixed the projector. So when you come here, you can directly use it.
Cool, sounds good. I'll have to step away for a little bit because I have to like get lunch and get ready, but I'll be there in like half an hour. So yeah.
Yeah, for sure. Yeah, so let's go ahead. I saw there the one person join. Okay, so let's go ahead talk about the domain. So in domain, so it's kind of like the function range, right? In mathematical term. So in our case, it would be the all possible values in the attributes we can have. So for example, in our dish table, so we limited, for example, like a name, it should be text. And for the type, it should be text. And then for the cost, it was gonna be integer, right? From 0 to infinite. And the second part, we want to talk about the tuple. So the tuple is kind of like in mathematics, it's gonna be the final sequences in the ordered list or numbers, or more generally, the mathematical objects. So in our case, a tuple is kind of like the fries appetizer for something like that. Basically, is the element of row, if you think about it. And the last part is the schema of relation. So the describe of our relations gonna be denoted by R, A1, A2, A3 to AM. So R basically represents relation, and A1 to AM basically represents the name of the attributes. For example, in R relation here is kind of like dish, right? And all these attributes from is going to be name, type, and the cost. And remember, we've already defined the domain. So basically, each attribute has a domain, and a relation is kind of like a set of the tuples. And the last part is about the state. So we're going to define the Cartesian product. I don't know if you guys heard this word in mathematics. Basically, if you have two set, like A1, XYZ, and 1, 2, 3. So basically, you can kind of like combine all of them into kind of like a small parentheses, right? And then combine all of them and do one element map to each other for each set. So basically, this do the Cartesian product. For example, we have 3 elements in A and 3 elements in B. So the total elements in this Cartesian product can be 9. And what does this mean? So it means, for example, in our dish table, if we only have one row in dish table, we have, for example, we have 2 type of dish and 2 type of entries and 10 cost, for example, from goes to 0, 1 to 10, they're typo. So the total possible combination gonna be 2 times 2 times 10. Okay, basically this is the summary of all this mathematical definition we're gonna use not only in this one, but in also in the future exam and projects. Any question here for all these definitions? It looks okay. So I'm gonna go ahead and go to the next part. And now in order, okay, since there's a, okay, so now I want to basically talk about the functional dependency. Actually, this part should be covered in future lectures. The reason why I want to introduce a functional dependency is basically for the better explaining the keys. So if you remember from the lecture, we have defined multiple types of keys, right? Like a primary key, a super key, and the candidate key, etc. So we kind of like formalize all this definition to make it more clear. So a functional dependency x to y means that x colon can determine y colon in a table R, and not vice versa. So basically, this is kind of like if you remind from the math, they're going to be kind of like a function defined like a y equal to fx, something like that. So basically, this is kind of like a functional determinant. So let's take a look over the left table. So in the left one, can we say x determines y?
No,
No, right?
because yeah, there's the two of the same X value, but they map to 2 different Y values.
Yes, that's exactly correct. Yeah. And how about the second table?
Yes, I think, at least based on given values, because every unique X value maps to the same Y value. Like, there's 3 ones, but they all map to 2, and then 2 and 3. Actually, no, that one's no 2, because 2 and 3 both map to 4. I missed those last 2.
Okay, yeah. So basically, the second one is also second one is kind of like a functional dependence, right? X can determine y, because we can have y. For example, 2 maps 4, 3 maps 4 is fine. but you cannot
Oh,
have
so I was right the first time, okay.
yeah, you cannot have one X map to different values. For example, you cannot have one map to both 2 and 3. So in this case, the first one is false and the second one is true.
Okay, got it, thank you.
Yeah, makes sense? Okay, and the next part, we're gonna talk about the keys. And firstly, I want to talk about is a super key. So basically, is a side of columns that which can determine the table. So remember, I forgot to bold this line. So it's side of columns. It can be one, it can be multiple, and the candidate key is kind of like a side of columns. Still can determine table, but if we remove any columns from it, so you cannot determine the table anymore. So there's a kind of more serious this definition here. So basically, I just read it. If X is can let me zoom in this part. Give me 1 sec. Okay, so if X is the candidate key of R, then X to R and every strict subset Y belongs to X, Y cannot lead to R. So this is kind of more strict definition. For example, if the columns KR are the columns in the table and the key is primary key of the table, then and R is and then KR are super key and the key is the super key and the candidate key. So basically, in my understanding, that candidate key is kind of like a minimal super key. And I remember is that take a look at textbook slides, they define another term called a key, but generally we don't really use that anywhere. So I don't mention that definition, but if you guys are interested, you can look at like the textbook slides.
Why is K a super key? Is it because it's a primary key?
1 sec, you table and the case primary key or table. So okay,
I like,
I
yeah, I
think
understand why KL is a super key. I'm just
I
confused
think
as to why K is a
there's
super key.
a typo here. So
Okay,
basically, I want to mention that both K and R can determine each other. So that's KR combined. Okay, the reason is that we only have 2 columns in the table, right? So KR definitely gonna be a super key. We only have 2
Right.
columns, right? So definitely from KR you can lead to anything. And we already mentioned K is the primary key. So that's a reason why key gonna be both super key and
Wait, could you say that last part again? Sorry.
yeah. So yeah, go ahead. So basically, in this table we only have 2 columns, right? K and R.
Mhm.
So if we include every single columns in this table, definitely you can determine this table, right? So
Yeah, if you include every single column, yeah, that would, and
yes.
that set of columns would be a super key.
Yeah, so that's the reason why KR is super key.
Yeah,
Yeah, and we also mentioned that key is a primary key, right? So you mean
right.
the column K can determine the table. And from the definition of candidate key, we know key is only one there, right? You cannot remove any kind of like element in that key. So that's the reason why KR is the super key and the key itself is both
So is,
super key and
okay.
candidate key.
So is any primary key going to be a candidate key and a super key then?
Any primary key. Okay, I'm gonna talk about primary key in next slide, but yep.
Okay, alright,
Yep.
sure.
Okay. Yep. So if a relation have several candidate key, and one of choosing arbitrarily can be the primary key. Okay, and a foreign key is a set of attributes in a table that refer to the primary key of the another table. So basically, we could have multiple candidate key in our table, but only choose one of them, right? So in this, for example, in this dish table, so which can be the which are the candidate key or super key?
Well, I guess the candidate key, I think, is name. I don't think type can be a candidate key because it has some values that are not unique. Super key, I don't know, would the super key be would it be name and type and cost? I'm still confusing the difference, but that would be my
Okay, yeah.
guess.
So let's go to the candidate key first, right? So candidate key gonna be kind of like a minimal super key, right? So in this case, we can see name itself can determine the whole table, right? For example, name definitely gonna be one candidate key. And another, if we notice, because I deleted some columns in a table, so the cost here still can be a candidate key because they are unique, right? You can determine the whole table.
Yep.
And remember, super key is kind of like what can determine table. So for example, I can include everything, right? Include everything into one set, for example, name, type, and the cost. So that's gonna be a super key.
Mhm.
And if I combine, for example, name and type is fine, and then type and the cost is also fine. Name and cost is still fine. So these are super key.
Okay, so a super key just has to contain one candidate key, basically.
Yeah,
That's what you're saying. Okay,
yeah.
so like type by itself cannot be a super key,
No.
but type combined with one of the others could be a super key. And then name or cost, since they're both candidate keys, each one by itself could be a super key. And then basically any combination or a single that's like one of the candidate keys that has one of the candidate keys is a super key.
Yes, that's right.
Okay, got it. Okay.
Actually, I talk about this part, but mostly if you guys more interested on that is about the normalization. So basically, we're gonna define from this functional dependency, we're gonna lead to some closure definition, and then you're gonna lead to some normalization problem. But that's about the future lectures. We don't really care about it at this point, but you guys still should familiarize with all these concepts in the keys.
Sure.
Okay, so basically we have three types of constraints. First is called the inherent or implicit constraint, and the second gonna be the schema based or explicit constraints, and the last gonna be the application based or semantic constraints. And we're mostly gonna focus on the second one in this review. And first, I'm gonna talk about the key constraint. So basically, if we're having the value which already existing in the table in this same relation, they're gonna cause violation of key constraint. So basically, the value exists mostly we're gonna means to the primary key. So basically, we cannot have the duplicate primary key in this table. So I have an example here. So if I insert dish site name equals bone where the name is ice cream. So if I update that dish, so we're gonna have two ice cream in this dish table. So that's really gonna violate the key constraint. And the second constraint is called the entity integrity constraint. So basically, we cannot have no value in our primary key. So if we do something like, go ahead, yeah, go
Could
ahead.
you go back to the previous slide really quickly? Sorry, I just
Yep.
wanted okay, so the dish set name. So why is this a key constraint? Oh, so set name equals bun where name equals ice cream. Why is that? Why did you say that was a key constraint?
Yeah, so if we let this happen, right? So we're gonna update. Basically, we're gonna have two bumps.
Oh, we have two buns. I see. Got it.
Yeah,
Okay.
so basically that's duplicate primary key, right?
But if you change ice cream to something like if you change it to like pasta, that would be valid, right?
Yeah, that works.
Okay, okay, got it. Thank you.
Yeah, no problem. And basically, by the way, I need to mention my point that I use the word having. So having meant there are gonna be more complicated cases, not only in the update, but the insert also gonna be included. And also if we want to insert kind of like the duplicate key still doesn't work. So I just want to cover more cases here. So I use the word having. And the second part is the having no values to any part of primary key. It's kind of like violates entity integrity constraint. For example, in this case, if I insert into this table called no entry 8, so it's gonna be violation of the entity integrity constraint. And this can be more complicated. So basically, I just use really kind of like an easy example here for the demo, but it can be more complicated. For example, we're probably gonna have a composite primary key, right? So in that case, it can be more complicated. But for here, I just make it easier. And the last part is about referential integrity. So basically, there's a definition I just literally get it from textbook. So we have a relation. Relation means we have two tables involved in this relation, right? And then, so if we are as a kind of like a reference table, we reference its primary key. So in our own table, it will be the foreign key, and we have foreign key. It can be either the value of the existing primary key in the crystalline table, or it can be null. But in the second case, the foreign key in our relation should not be the primary key. This sounds a little bit complicated, but does it make sense?
Yeah, that makes sense. You're basically saying that the foreign key column in the table, it can have like it can be either a like an existing primary key value in the other table, or it could be null. But if it's null, like that value cannot be in the actual in the other table, because that foreign key for this table is the primary key for that table, and primary keys can't be null.
Yeah, that's right. Yeah, that's exactly what this words talk about. But yeah, but I mean for the clearance, I just literally copy everything from slides. Okay, so I give some quick example to kind of like a demo the integrity constraint. So basically, we're gonna have two tables here, and one is dish, another is customer, but we're gonna have the customer table, one column of customer called launch. They're gonna reference from the dish table as is a foreign key. So we have this policies here, which is a update restrict and delete restrict. So if you guys looking at the textbook slides, remember we have 3 types of policy, right? Restrict, custod, and set to null. So so I cannot cover all this here, but I think the most interesting one is about restrict. For other two, like update or set to null, it's still kind of like the similar, but I just give most important here. Okay, so if we have two table here, does this statement looks correct? So basically, we're gonna update this set to name to bomb, where name equals pork.
No. Well, yeah, I don't think so, because there's already a value in the name column called bun in the dish table.
Yep. So remember, we don't have the name pork here, right?
Yeah, so like it's not going to actually do anything, but if
anything. Yeah.
but if the entry like existed, then it it would be like an illegal operation because there's already a bun in the name column, right?
Yeah, that's right. Okay, so if I okay, yeah, the first one is invalid. Yep, because basically the pocket does not exist, and yep, and secondly is we're gonna insert into the customer table with this following value 20, 30, and no. Is this statement okay?
Yes, that's fine because, there's no, first off, there's no Tony in the primary keys. And 30, I mean, age is just a regular column value, so that's fine. And then lunch is a foreign key for dish. But null is not, so it can be null. And I think, yeah, it just can't have it just can't be part of a primary key for this particular table, and it's not, so I think that is valid.
Yeah, that's a valid statement. Yeah, and your explanation is totally correct. And next one, so we're gonna update the customer table assigned to lunch equal to equal to ice cream, where name equal to the reward law. I don't know how to pronounce this word, but yeah. Is this statement okay?
Uh, so that references name. I actually, I don't know. Okay, so it says us update customer set lunch equal to ice cream. Where name is ravioli, okay?
Yep.
No, yeah, I don't know. I couldn't tell you. I don't think so, but I'm not 100% sure.
So what's your guys' opinion? If you guys type 1 meant is valid statement, if you guys type 0, it's meant invalid statement. Let's have a poll here. So what do you guys think in person? What do you guys think? Is this statement valid or no? You don't think so? Okay, how about you? You think it's valid? Okay, I get a half for the in person. Okay, so this one is okay, invalid. I think I got more invalid than invalid statements. Okay, so actually the results here is we can't we are okay, we are able to do that. So this statement actually validated. The reason why it's here is because so say even though I guess you guys reason why it's invalid because it's kind of restricted, right? Is that where you guys from? So okay, I say something yes here. Yeah. Yeah, so if this restricted, for example, if you want to do that, probably you cannot do that, right? But however, because the customer, they are children table, right? So we don't really care about the children tables for the reference part, so we can easily modify it. For example, the ice cream or whatever, or I mean, you can even delete the Mary colon. It is fine. I think all of this case is fine, but you cannot modify the primary key in any way. So means in the dish table. So you cannot modify the parent table. Does it make sense?
Yeah, so, okay, so you're saying, okay, so update customer, so that's, it's okay because you're not modifying dish at all. You're just only modifying customer. Is that why you're saying it's okay?
Yep.
So, okay, can I ask a question then?
Yeah, go for it.
So, okay, so, let's say that you want to update customer, like, so I guess this is saying where name is right. Let's say you want to, let's say you want to update it where name is something else, like say name is Tom, and then you want to set lunch equal to, let's say you want to just set equal to pasta, right? So pasta is not a value in dish. Dish is primary key.
Okay, let me write it down. I think this is really a good question, by the way. So let me write this question down.
Sure.
So it's really I'm gonna literally have another segment here. So I think it's good to discuss what you just talked about. So you want to
So yeah, I want to update customer where you set lunch equal to pasta, something that's not in the dish table.
That's it,
And
right?
yeah, name can be like Tom or something, some entry that's already in customer, that's fine.
Yeah,
So in that case, would that be like, is that a valid transaction? I'm asking because pasta is not a value for the primary key name in dish, so would that be valid or invalid is what I'm trying to figure out.
yeah. What do you guys think of second statement?
I
don't
think it'd be invalid, but I'm not sure.
invalid. How about you guys think of the second statement in person? And you guys can still type 0 for invalid and 1 for valid for the Zoom people. How about you guys think, is this statement valid or no? For this second one? Any ideas? Invalid? How about you? Why not? Why not? Is valid or not? No valid. Oh, sorry, what? Oh, okay. So one person asked me, post all the slides on the ad. Okay, give me 1 sec. Let me.
Yeah, of course, take it now.
Okay. Okay. Yeah, I just posted the slides on the. Yep. Okay, let's go ahead and go back to the slides. Okay, yeah, so let me take a look at the room chat. So okay, I say some zeros. Okay, basically this is a good question. It depends, actually depends on the SQL version and the engines. So for example, what you basically mean for second statement is that you want to have some reference some primary key which does not exist, right? in the parent table. Is that what you're
Yes.
going to? Yeah, so it just depends on the SQL version and the primary key. For example, if you you use MySQL and the engine gonna be storage or something, in that case, you cannot do that. But I know definitely in some SQL versions or some engine, you can have that. So it depends.
So for the exam, what should we, what should we assume in this case?
Good question. So currently, I don't think the exam gonna cover this edge cases. If it covers, just
Okay.
let us know. Yeah,
Okay, got it. Thank you.
this is pretty edge cases.
Yeah, I was just trying to figure out like all scenarios, so.
Yeah, I mean, generally, so from what I know, past exam, I'm gonna assume that most ideas or the concepts are literally the same from what I demo, but they're gonna be more tricky. For example, you're gonna involve like 5 or 6 or 7 tables and with relations to each other, and then they're gonna, so all the demo I use here is called update or delete restrict, right? So in the exam, it can be assigned to null or casted. So all of those should be taken in consideration. But as long as you
Okay.
understand the basic concepts and do some practice questions, I think you guys are fine.
What is meant by update restrict and delete restrict exactly?
Yeah. Okay. Yeah. Sure. So basically, in this case, customer in our children table reference the dish name in its parent table, right? So basically, customer is a reference to the dish table. And it meant that we can modify or delete any values in a dish table as name. For example, you cannot delete bun or delete ice cream or update the ice cream to another, name.
Okay,
So if you do it in a SQL, you're gonna give you error. So basically, this is how the integrity constraint gonna be.
gotcha,
Yeah.
okay. And
Any
then, okay, got it, thank you.
Yeah. Any other questions? If you guys have any questions on this reference constraint? Okay, so since there's no question, so I'm gonna go to next part. So basically, I include two maybe six questions which try to cover these concepts. So I give maybe 2 minutes for these two statements. Yep.
Should we,
You guys just can type 1 and 0 to say if
okay,
it's in the-
for
yeah.
like are we doing the first one right now?
Yeah, you guys finish both 2 minutes.
Okay,
I think this exam is gonna be much harder. You guys probably gonna use all the time, so just do it as quick as you guys can. Yeah, do you guys have any questions? This one? Okay. Okay, 20 seconds. Okay, so how many people think the first statement is okay? Do you guys think? What do you guys think? No, okay, right? Why? Yep. Yeah, that's right.
I think the first one would be okay if it was update instead of, like if you're updating the value to be 8, the cost to be 8. Instead of trying to insert a whole new tuple in. But because you are trying to update, insert instead of update, I think that's what makes it invalid.
Yeah, that's right. So basically, for all these key errors, so it means that we cannot have two duplicate primary key in our case. Okay, in how about second statements? What do you guys think?
No,
No,
I mean invalid because you can't have null as a primary key.
yeah, that's totally correct. So we can have a null in our primary key. Okay, so yeah, these two are gonna be a little bit more complicated in exam. So I guess the case in the exam is gonna be, for example, composite primary key, right? And you're gonna be reference primary key from another table, something like that. But general idea is still gonna be same. So the general idea is for the key constraint is you cannot have the duplicate primary key, and for the integrity entity integrity constraint, you kind of have null in your table. So general idea is that, but it's gonna be complicated in the exam. Okay, so yeah, I still have another 4 more statements. So I'm gonna give maybe 5 or 6 minutes to finish all of them.
4 minutes.
Yeah, 4 statements. You need to determine. Yeah, all of them is invalid or not. Yeah, I don't know how many questions you guys gonna have in exam, but definitely it's more than that. And the relation can be more complicated. But okay, 2 more minutes. Sorry. Oh, there are 2 tables in our. Yeah. Wait a second, is there a typo? Oh, there's okay.
Yeah, I put that in my comment in the thing that I thought there was a
sorry,
syntax error, but
there's
you can,
there's a
yeah,
typo.
so, okay, I thought so.
Okay, sorry. Yeah, so generally you then won't be that kind of like a typo. Hopefully, yeah. And I don't think you guys gonna allow my SQL to test in all of the different exams. So yeah, yeah. The goal of exam is not use a SQL to do all these statements, right? To use a SQL to say is they valid or not.
No way.
Are you done? Nope, almost there. Yeah. Okay, time is up. So how many people think the first statement is valid? How in person people think? And for the online person, you can type 0 and 1 for the first statement. Okay, what do you guys think? Oh, first statement. Is this valid? And if you know valid, what error it might be in our case? Yeah, first one, first statement. Okay. Okay, so is it valid or not? Valid or not? Sorry, you are not sure?
Because you're like,
Okay, so. Okay, so I'm gonna give the solution then. So basically, the first statement gonna be the valid one. So the reason why is that is because
Wait, it is valid or it's not, you
it's
said?
the valid one.
It's valid?
Yeah,
Okay, good, okay.
yeah. So the reason why is valid, remember as I said, right? So we remember there are two scenarios of our foreign key constraint or the reference constraint is that if we want to have a primary key, it can be either the reference to a parent table's primary key and what is existing there, or it can be no. But if the foreign key is no, so we cannot use that foreign key as the primary key in our own table. So first statement valid. Okay, how about second statement? No valid. Okay, I go to. Okay, so tell me why.
I think there's.
Two reasons. Okay.
Yeah, so first of all, you're referencing ice cream and custard from him.
Yeah.
Which is not something that you can do with them. And like. Primary, first, it's a primary key, diff, right?
Yep.
But then you're also referencing the primary key in customer.
Good. This
There's
yeah,
two,
two errors, right? Basically,
at least two.
yeah. Basically, that's right. So basically, second statement violating two rules. Firstly, it violates the key constraint. So basically, we can no, sorry, entity integrity constraint. So basically, we cannot have the null in our dish table, and also remember all these policies are still restricted, right? So in this scenario, we cannot have we cannot directly modify the primary key if it's a update restrict and delete restrict. Okay, let's go to third statement. What do you guys think? Is it valid? No. Yes or
Not
no?
sure, no
Not sure?
clue.
Okay, you think it's okay? Yeah.
I
How
think
about-
it's okay.
You think it's okay? How about other two? You're not sure? Okay.
Pick one. Okay, cool.
Okay. Sarah, what do you think? Oh, okay. So yeah, so this one gonna be the valid because basically, if you think about it, right, we just delete something from children table. There is no reason why we cannot do that, right? However, in exam, it's gonna be multiple table reference my primary key. In that scenario, you need to take a look in each children table to say if this similar words to say update restrict and delete restrict. If that's a scenario, you definitely cannot delete column. But in this case, since no one reference the customer, right? So we can just delete any column or change any column and do anything you want. Okay, last statement. What do you guys think? Is it okay?
No,
Okay, there's a okay. So from in-person people, I saw there's a okay, right? It's okay, yeah. Okay, but you said it's no. By the way, what's your
I said no because it says there's an update restrict.
name? By the
So
way,
that,
what's your name?
or sorry, delete restrict.
Yeah, delivery straight, yes. But what's your name?
Pranav,
Pranav, okay, Pranav
Yeah.
is not okay because there's a restrict and delete. Actually, actually, Pranav is correct. Even though I make it a little trickier, the bond is not in the customer table, right? So basically, since no one reference it, but actually the restrict gonna working on the whole column. So basically, even if no one reference it, it's still gonna be no.
Okay, but it wasn't restricted.
Yeah.
Okay.
Yeah, if there could be some set null or cassette in that scenario, you're gonna be okay. Yeah, does that make sense? Or any questions on this?
yeah, I have two questions. So first on the second one.
Yeah.
Is the second one, wouldn't it be there's false for two reasons. One, because there's an update restrict on dish, and two, because a primary key can't be null. So for
Yeah.
both those reasons, it would be null, it would be false, right?
Yeah, that's right. So,
Okay,
yep.
and then for this most recent one, even like, for example, if you had delete from dish where name equals Jack, for example, it would still be in, or. Sorry, yeah, delete from dish where name equals, sorry, delete from dish where name equals edamame, like something that's already, that's in the table. It would
Okay.
like, it would, oh wait, no, wait, but bun is in the table, I'm stupid, okay, yeah, so that one's invalid because there's a delete restrict on dish, right?
Yeah.
Okay, got it, okay, thank you.
Yeah, that's all the way. So you guys don't have any question, right? Okay, one question.
So I missed this part, what does it mean when it says update restricted delete restrict?
Okay, so basically this question is asked about update restrict and the delete restrict, right? So so remember, okay, let me go to the previous slides. So remember, we have this kind of like a referential integrity constraint, right? So for all this relation in our states for relations, we have two tables. One is called parent table, right? It has its own primary key, and then we have the children table, which has its own foreign key, which is reference to its primary key in its parent table, right? So if we want to do any modifications or updates or delete on the parent table, so since our children reference the primary key in the parent table, right? So we have some rules there. Does that make sense? So the rules can be update casted. So it meant that if we delete the primary key in our parent table, so any column in the children table who reference to that line or that column can be deleted. So that's kind of like update and this delete casted. And the second is the second null is that if we delete certain column in the parent table, so all the children columns that that column can be set in null. The last one is currently what I have restricted. So basically, you are not allowed to do so. It's gonna give you error. Yeah. So this is kind of like three types of the policies. Okay, there's since one question on the Zoom. Okay, the question is will there be question regarding to the? Yes, there gonna be questions on there, and the Sarah is gonna, yeah, Sarah is gonna cover this part, and I think the second part is not as straightforward as this part. I think this part is relatively easier, but in the exam still pay more attention. Please pay more attention on all these relations on the children table and the parent table, because all the example here, I kind of like toy example, right? I only have one reference to his parent, but in exam, they're gonna be 3 or 4 children table reference his primary key, and you're gonna have different updated policies. Okay. That's it. And I have one small announcement is that we're gonna release a middle semester survey, maybe tomorrow or something, and then basically ask you guys feedbacks about all these after lectures, review sessions, and maybe project party, and yeah, and if a certain amount of people finish the survey, so we're gonna give some extra credits. Okay. Yeah, Sarah, come here. Yeah. Okay, Sarah is gonna take over me to finish the second part.
I'm pretty joining the session this week.
Okay, you're gonna join the. Okay, I'm gonna make you a co-host. Yep.
This meeting is being recorded.